Alright, this I should fly through because you've learnt this in the past.
Just so
Okay. Alright, so longest side of a right angle is called hypotenuse. Nice. She's so alert in here. So the first thing we're looking at is right angle trigonometry. Okay, so this is right angle trig. So if you've got the right angle in the leg opposite that, it's called the hypotenuse. Remember, for normal circular, they'll label, or you'll be asked to find one of the other angles. So your other labels, the other two lengths that you're going to label depend on which angle you're interested in or asked to find. Okay. So this one here, if this is the angle they've marked or we're needing to find it, then this one is called the what? Opposite. Opposite. Nice. Because it's opposite. Clever. And this bad boy is called the adjacent. Nice. Because that means next to. Oh, I thought I'd changed the title. Sorry. So adjacent means next to. So I would always suggest that you label H, then O, then A. I think that's the easiest way. I don't know how you teach it in the past, but this is how I teach it. So for every value of theta, there is a special value for the ratio of one side divided by the other. The sine ratio looks at which two sides?
So,
and then cosine is the adjacent over the height.
yes.
And tangent looks at opposite over adjacent.
Okay.
Now, you've been taught it before, so I don't know how you've been taught it, but I teach it like this. So rather than just saying SOHCAHTOA, we have the middle letter up in the air, which means that you don't have to worry about your rearrangements. Because if you're trying to find the opposite length, you cover up the O and it works like the speed distance time triangle. So the opposite length is the sine of the angle multiplied by hypotenuse. If you want the hypotenuse, you cover up H, it's the opposite divided by the sine of the angle. Okay, so just by writing that middle letter up in the air means that you're able to, as I say, use them like the speed distance time triangle. Remember that if you are, okay, so that's SOHCAHTOA. So finding angles, remember that you're going to be using your inverse buttons. Okay, check to see what mode your calculator's in and what you're supposed to be answering. And so are they in radians or degrees? Because the only time it matters, I think I said this last time, the only time it matters about your mode is when you use the sine, cos and tan buttons. If you're just using it to find sector area or sector arc length, it doesn't have to be in the correct mode. Okay, but if you are pressing these buttons, then the mode is important. Okay, so if you've got sine theta is 0.5, theta is, do we know what it is? By half. How you chuck it in the calc and you find it 30. Yeah, we're gonna learn that. If tan theta is 1, then theta is, oh, I can't remember. Can someone chuck it in their calc?
100. Someone got their calc out?
Yeah.
45.
45. Thanks, Amy.
Ooh,
You're just so funny. Oh, I didn't actually write this. Sine to minus 1. So you're chucking in sine to minus 1 of 0.5 and sine to minus 1 of 1, obviously. So as I said, you need to check the mode of the calc. So steps to follow: label size HOA, decide whether it's sine, cos, or tan. It was 45. Then write your appropriate statement and then solve it. So for here, I'm trying to find this angle. So I'm going to label HOA. Which of these is irrelevant to me? Okay, so I'm going to cross that out. I've got H and O, which means we're looking at so. We're trying to find the angle, so when you're trying to find the angles, you'll always be covering up the S, the C, or the T, because that's the letter that goes with the angle. So the sine, the cos, and tan have to be attached to an angle. So we would have sine theta, cover up the S, and it's O divided by H. So sine theta is 5/11, which means that theta is sine to the -1 of 5/11, which is, the rest of you are going to get your calcs out at some point.
I just don't want to.
Oh my god, fantastic.
I'll let you go and do it.
Now we're in degrees. We're answering these in degrees. 27? Is it point anything? Okay, so always put the point 0 into 360. We're working degree mode for that, yeah. Get the talons working.
How you can do that? She got it at 1.
Okay, so same meter, not same meter group. So we're labeling H, O, A. You hold up. You're quite bold today, aren't you? That's weird. So we cross out which letter here?
H.
Which means that we're using. Oh my gosh, it sounds kazoo. What's going on?
I just need a little.
Oh, I mean, Free love it. I mean, she's fine. Oh, it's just a face girl. No, Bobby, not. Oops, sorry for lying, guys. All right, gonna watch it. So, she's never gonna watch it. So, tan theta equals, cover up the T, it's opposite over adjacent.
Do you have to show the steps?
You don't, like, you can go straight to this if you wish. 53. Point.
I was probably a friend, yeah. From the Senate secretary.
We're going to the Senate tomorrow for the conference.
That's just plain off. Right, okay, we've got that.
Exactly that?
Alright, you guys have to go at those ones.
The mayor?
Yeah,
I do that every time.
Alright, okay, so hopefully, what did we get? You'll get the same things.
I ain't even worked all of them up yet.
So was it?
yeah,
And,
5 over 17. Yeah, 5 over, yeah, 15. 5 0.
oh, thanks.
45.6. And 60.
Check Bertie. Do we remember something special about these numbers?
Are they like the triangle thing, the special triangle?
No.
It is.
And notice I've only chosen some of them. I didn't choose that one. These numbers for the sine or cos cannot be more than 1 or less than -1. Okay? So if you ended up with 19 over 12 and tried to do inverse cos, it would say error. Okay, and the reason is because it was more than 1. So this value here has to be less than 1. Alright, so just so you know. But you also know that because we've studied the sine and cos graph, yes? And we know that the maximum value is 1 and the minimum value is -1. So if you've got a value more than that, obviously you know it's incorrect. The tan could be anything. Alright? So that just helps a little bit sometimes to make sure that you know if you're going the right way around. Finding sides, same principle as we just got done. This time we are trying to find the missing length. So we're going to label and do stuff as we did before. So H, O, A. Now, it's these kinds of questions people tend to, now, they have labelled this A, but it's the opposite side, so you have to be aware that sometimes that does happen, okay? You don't, to be honest, you don't get many right-angle trig, it's more the rest of the trig, but what I'm going through it just to make sure you understand it. So, they labelled theirs A, could have been X, could have been anything, right? So the fact they labelled theirs A, it's the opposite side. Now, it's at this point lots of people go, well, I don't know which one to choose. It's so car or toe. So you decide which of your three sides has not got any label on it whatsoever. It's A. So that's the one that goes. So whilst you don't know the opposite length, you're trying to find it. So it's involved in your question. So we're using so again. And so this is where the rearrangement tends to come in more useful, as in like the speed, distance, time thing. So the opposite is what we're trying to find. So opposite is sine multiplied by hypotenuse. So A is sine. Now sine has to be attached to what? 42. The 42, good. And then we multiply by 15.1. Be careful, because I think especially on your calcs, it's very easy to accidentally type multiply by 15.1 in your bracket. So make sure your bracket is closed and then you do the multiply by 15.1 at the end of it. So I don't know what that answer is. HOA, so HOA. So this is a H and A, so O is useless. So this is a car. We're trying to find the hypotenuse, so this is where we put H and A divided by cos. So Y is 6.2 divided by cos of 38. Well, you've all got the answer somewhere. What is it? 7.87. I'm not putting units, and I should be. Just double check when you're writing your numbers. Like, so we're finding the hypotenuse there, so we know it has to be longer than 6.2. Just have that in the back of your mind. Excuse me. So H O A. So this one doesn't need H, so it's a TOA. So we're trying to find the opposite side, so it's tan multiplied. So P is tan 62 multiplied by 8.3. Muchly. And then I think I've got some for you to practice. So you can practice those diagrams. Right, so I don't know what the answers are.
No, you spoke.
What are these? Do we care? Yeah, I guess.
Yes.
No,
Wait,
no.
the first one.
There's some.
There's
Oh, that's not the top one.
yeah. There's 7.8, yeah. 15, so like 36.4.
What, you studied? I didn't.
11.7.
8.2.
2.7.
Trisbians. Okay, so good old SOHCAHTOA. We're good to go. Right, as I said, that doesn't normally come up. So sadly, don't get too excited that you're like, yeah, I've got that stuff. Special triangles. Here's the joyful thing. Have you learned this before?
Yes, but I always messed it up.
I was never good at this.
All right.
Ambiguous case.
Ambiguous case comes up, but this is basically you would have learnt this doing CIE because you have sometimes trig things on a non-calculator.
We did, yeah. And we drew up triangles.
So Similar situation, you're going to have a non-cap paper, sometimes you're asked to solve stuff. So you do have to be aware. But the reason, do you remember I was saying the other day about the values that I chose to change for radians? Is they're the ones that come up. So it's only going to be a 60-degree angle, a 30 or a 45. Okay, so they're the three that you're interested in. If it's 0 or 180 or pi over 2, then you can tell them from the graph, from sketching the graph. So the other ones, the weirder ones, are the 60 and 30 and 45. Right. I would suggest, rather than learn the table that we're going to end up filling in, that you learn how to draw the triangles or learn the triangles themselves. Okay? So how do we begin? Well, this left-hand one is an equilateral triangle of side length 2. With that equilateral triangle, I've now cut it into 2 right-angled triangles. Yes? We know that equilateral triangles have angles of 60 degrees. Yep. Which means that when I cut this one in half, they're 30. Okay? So I'm going to transfer that now to this triangle. Yeah? So I know that this is 30, this is 60, this is 1 because I cut it in half, and that's 2. Well, obviously I'm missing a length, but we can use good old Pythag for that. So that's going to be, it's a short side, so it's going to be 2 squared subtract 1 squared, and so it's 4 subtract 1, which is root 3. So your triangle that you need to learn is 1, 60, 30, well, 1, 2, and root 3, and then 60 and 30 again. The other kind of triangle that we look at, and we need to learn about, is an isosceles right-angled triangle. So for an isosceles right-angled triangle, these are both 1. The fact that it's an isosceles triangle means that these are both 45. Okay? Because we know that angles in a triangle have and this one's 90. So this one here, again, we're using Pythag. But this time it's the hypotenuse, so it's 1 squared plus 1 squared, which is root 2. So you just need to learn these triangles. Now you might think, well, that's really hard, but it's not really. And if you remember how we got it, it's even easier. Yeah? So there's the 2 triangles. Now, how does that help? Well, we know SOHCAHTOA involves these lengths. So if I were to focus on, what am I focusing on first? Well, such a big gap. If I want the sine, if I'm looking at sine and I'm trying to find the sine of 30, I'm going to find my triangle. The sine is the opposite over the hypotenuse. So it would be 1 over 2. So that's 1/2. Yes. The sine of 45, so let's go to the other triangle. Sine of 45, doesn't matter which angle you're looking at. Opposite over hypotenuse is 1 over root 2. It may well be rationalized. Do you remember rationalizing? Which makes it root 2 over 2.
You have to what else? Yeah. That's when you get rid of it.
So if you have 1 over root 2, you need to get rid of the square root sign. So you're going to multiply it by 1. To get rid of the square root sign, you have to multiply it by root 2 over root 2, because that's equivalent to 1, which becomes 1 times root 2 is root 2, and this gets rid of your square root sign. So that's rationalizing. 60, so go back to this bad boy. This time we're looking at the 60-degree angle. So its opposite side is root 3, and the hypotenuse is 2. So that's root 3 over 2. Yeah, we understood how that goes in? So you can fill in the other two bits in the chart. Alright, so from the triangles that we get those other values. Now, The tricky thing by not learning this table is that sometimes you may get a statement that says something like cos theta equals root 3 over 2, and you need to solve for theta. Okay, so by not learning the table, you need to be able to still use those two triangles to get your correct angle. So you need to establish which length needs to be the adjacent, which one has to be the hypotenuse. So for my adjacent to be root 3 and my hypotenuse to be 2, then my angle has to be 30. Does that make sense? Yeah? Yeah? So I definitely think it's still better for you to have the triangles sorted rather than learn the table. I do remember hearing lots of people just recite values. I personally don't think that's as helpful, because when it comes down to an application question, you're not really sure what you're doing. So if you just learn those numbers, you can't always go the opposite way. Yeah, often the value that you see is a bit of a giveaway. So if you see a root 3, you know it's not going to be a 45-degree angle because there's not a root 3 on that triangle. So it has to be either 60 or 30. So even if you're not sure, you can just guess. Okay. That's great. Right, I'm going to pause there. Because you learned it all before. All right, sine, cosine, area formula. Yes? Ooh. Don't you get given them before? I think you might. I think you do get given them. In fact, you get given both. You get given the rearrangement. Remember at GCSE you had to learn the cos? Yeah. For the cosine rule, you had to learn the cos A equals. This you get given everything. So fear not. So whilst the initial SOHCAHTOA is only for right angles, okay, so SOHCAHTOA is only right angles, the sine and cosine rules are for any triangle. They are formed by, if you have a triangle ABC, its opposite length is labelled with a baby letter. Okay, so this would be A, this would be the B, and this would be baby C. So just remember that the connections are between the angle, bless you, and the length opposite that angle. And sine rule, it states, remember it? A over sine A, B over sine B, C over, whoops, sine C. Remember, you're only going to use two portions of that, so you're only ever going to have one equal sign. If you're finding lengths, start with the lengths on the top. If you're finding angles, start with the sines on the top. It makes it much easier. So you're given it, so you just learn it. So for the sine rule, your question is going to involve two sides and two angles. Okay? So when I say involve, it means that you're finding one of those four things. So two sides, two angles means it's a sine rule. So here's our question. We've got x is what we're trying to find. So we have x over sine 32 is equal to 18 over sine 108. And then rearrange to get x on its own. And chuck it in the calc. Thanks. Keeping me on my toes is good. What's our problem here? Is there a problem? Angle. Yeah. What should we do, Queen?
We'll add.
Yeah. So the main reason I've chosen this one is because in order to find this length, we need to know this angle here. And so we can work that out because we know that they add up to 180. So we're going to do 180 subtract 26 from 46 to start with. So that's 180 subtract 72, so that's 108. So we know that angle is now 108. So we can now go back to the y over sine 108 equals 14 over sine 26. Okay, so we get 30.4 just the ends. So finding angles, as I said, for this one, just flip everything the other way. So it's easier to start with it on the top. So if we've got to find this angle, we'll start sine theta over 8.7 equals sine 110 over 11. So make sure your sines are level and your lengths are level. So sine theta is sine 110 over 11 multiplied by 8.7. And then obviously your final step is that you're going to inverse sine that answer. Okay, so we've got 48 plus 0. Next one. What's our issue for this one? Good, we don't have a length opposite this one. But we do have this length here. And so what we can actually do is find this missing angle using sine rule. And then we would subtract from 180 to find this one. Yeah? So it's kind of like the other way around. So don't panic and think that you need to use the cosine rule to find this length. You don't, you can just work at this angle and then subtract from 180. So we've got sine of that symbol over 125 is equal to sine 32 over 150. Okay, so there's that one there.